So hello everyone, my name is Chad Coarsey and I am from the Bionic Glove Project. We are located in Boca Raton, Florida. And we started out of Florida Atlantic University, our local university. My co-founder in the audience here, Perry Weinthal, approached me for a class project and said, "You want a hand?" And that's how it kind of all started. So from that, we had our company and we were providing some of the e-NABLE prosthetics and devices. And then we recognized that a lot of the people that were coming to us had maybe some anatomy that e-NABLE devices wasn't pertained to or couldn't really be built around. And so that kind of led us to the idea of 3D scanning. 3D scanning has been emerging, more on the cost side, going down in the past couple years. The one we're using is called the occipital structure sensor here. And later, I'll definitely have it in the back if people want to see. And just really quick, so people not here can see. This is the occipital structure sensor. Great. All right. So with this little design, we're able to kind of put together a 3D scan by simply plug and play. So the software that we use is called Skinect Pro. It's right here. And it has multiple modes of how you want to scan. So I've seen this used in the architectural industry, real estate industry. If people want to scan a room and have a virtual tour or have the architecture. Most recently, Notre Dame with the fire, we had 3D scans of that now that they've rendered. So it's ubiquitously used now. But what we can do is actually tailor it to someone that might need a prosthesis. And so that starts with, again, the scan. Any questions right now before I jump into it? No? Okay. So again, with the structure sensor originally, it ran off an iPad scanner. iPad with a bracket. And what we found was when we're interfacing with the Windows software, not on the iPad, when we're keeping it on the computer, with our workflow, we had some bandwidth issues because we had to stay intact with the Wi-Fi. We had lots of information. You can imagine a 3D scan, it's taking thousands of images at once in real time. So we have to have a significant amount of bandwidth and data capacity. And so what the structure sensor people have done is they created an open SDK and actually interfacing with the open NI2, that's a Windows driver. You can run it directly through Windows programs. And also, equally, you can run it using an Apple device too. And I'm sure Jeremy, who actually has mentioned that, can tell you more about it. But just for our purpose, I want to show you just how it works. So it uses a bounding box geometry here. We'll toss this one out. So within this bounding box is what it's looking for. So if you have an object within that bounding box, it'll trap it and recognize it as an independent object, and that's what it'll build the scan around. So I will quickly throw things together. So here is the bounding box parameters here. Typically 0.3 has been kind of a good number. We have a concentric ring now that we operate in to get a standardized scan, and that bounding box is ideal for that. We'll make this one just a little smaller, though, just because you're right beside me. And if you want to actually come around this side, I'm going to hand this to you. Okay. So once we get that started, we can actually move. Uh-oh. Don't worry about it. That's me. Let's see if we can get it back. There we go. Sorry. So once we get that all set up, we can actually move into the recording phase. So right now, you can see it's creating a heat map. So basically, if you look at Marty here, Marty's multicolored now, right? So that heat map tells you is distance. So you get colder as you move away, and you get warmer as you move close, right? And so similarly with anatomy, you can kind of gauge where your box limitations are and what dimensions you can work in as far as the scan itself. You do have to do kind of a little bit of thinking as far as your path of scanning. When you're taking a scan, sometimes when you're getting the side profile of an arm, there's just not enough anatomy there sometimes. So you'll see, you have it here, but as we get further and further away, it's getting, a little bit more inaccurate. So that's one thing you have to consider. Another thing is, it's not going to intuitively fill in a hole unless you tell it to in the processing software. So if you're missing a side or if there's negative space, you kind of have to think about that too when you're accounting for the scan itself. So I'm going to let you drive it, and I'm going to come around here so you can focus it. All right.
Is that good? Wait, you don't have to move that.
Okay. There we go.
Okay, fine.
So hit start when you're ready. So it's got my knee in there, sorry. But you can kind of see the general point. And you can imagine when we have this on a standardized apparatus that's concentric scanning, we can do multiple rotations of scans. And what you'll end up getting is a more finer and smoother and more robust image, 3D image of the scan itself, and more accurate. And what you want to get is that green. Green is good. So when you get the red, that's when you know that the anatomy is not being picked up or it's having some distance issues. And I think at the bottom you'll see it's measuring in frames per second. So you just have to be mindful of that too. If you move too quickly, you can kind of
Let's get the top side for now.
Okay, yeah, that's fine. So if you move too quickly, you can kind of lose some of that tracking and you'll lose the image. So that's another thing you have to kind of be mindful of. And so once we get the scan, we can do some basic processing too in these tools up here. I like to save the scan file as an original file first before I do any processing, so I have an independent file I can work from, part of our process control, right, that we were talking about yesterday. So in that regard, we create another image from that same scan and we can do processing. When we take these images, we can do exporting depending on which software you're going to be working in. Ideally, we have been using Mesh Mixer and AutoCAD programs to do all this work because you can just directly port in an STL. Similarly, for SolidWorks, you can convert this into an OBJ or export as an OBJ and then convert to a quad mesh and then pull T-splines to create a more formal object around that organic object. So, as you can see here, got a little bit of my knee in there too, but we have roughly a nice patterning of the arm itself. Obviously, he didn't get the underside of my arm, so we have holes there. But if you can imagine this in our setup with a concentric ring, we're getting every single angle, it's standard, and we're getting multiple passes of the same image. So it's going to eventually give you a very, very accurate scan. Any questions?
Yeah.
Yes?
At the very beginning, you had another setting there called body. Why don't you choose the body?
Body. That literally applies to a human. So like an actual body. You can actually do it so it scales the height twice, so you can do a full length body of someone too. And Perry, we went to a maker fair and they had one of these set up, and he has a full bust of himself, fully standing. It's the funniest thing. But yeah, you can do it with the scanner though. It's the things you can do with these scanning technologies is just amazing today. Yes?
Introduce Marty?
Yeah. Oh, Marty's also going to be giving a talk in a little bit, but yes.
Do you have a picture of your concentric scanning rig?
I will get to that.
Yeah, Marty will be presenting that one.
Good.
So yes.
Yeah, so the iPad app,
Mhm.
when you use just the iPad and you have it so that it's sort of, instead of saving it locally, you have to email it from the app.
So the interface between iPad and Windows is through the software exclusively. So when I run the iPad, it'll pick it up through, I believe, Wi-Fi. And so they both have to be on the same router.
So this is a different thing. You can do this one with absolutely no Wi-Fi at all when you take the scan.
This is directly plugged in. And then similarly, what Jeremy was doing is taking an iPad itself and not interfacing it into another program. So it actually had the software built into the iPad. And that's maybe something newer that they've done. And I'll also mention that this is like the older one. So they've come out with the Mark II, which is much more robust, higher processing power, probably 20 times better than this one. So I have a few more minutes. Any other questions?
So eventually one might want to print a replica of this, and at this point it's probably not a complete mesh, right?
Maybe I'm not fully understanding what you're saying.
It's an STL file. Can you send it out to your printer and get a 3D model?
So when I go to the share step, that's where that comes in. So you can export it as PLY, OBJ, STL, VRML.
Okay.
You can set the scale, you can set the number of faces, and then even the color space too.
Have you ever tried to print the resulting STL on a?
Oh yeah, oh yeah, oh yeah.
Mix it up.
Well, you clean it up
Or
before
you
you
clean it, so there's still a mesh mixer manual process of cleaning
How
the
big your skin
So another thing is too, you can do pre-processing in this software too. So one thing we definitely do is the move and crop, and so this allows you to essentially, eliminate most of that knee that's not necessary for our hand model, right? So that's one of the workflow steps that we do. Okay, any last questions? I will be in the back room if you have any further questions. Thank you very much.
Thank you.